I'm talking with you today about a project that I've been working on now actually for quite a long time. And it began in 2014 when I took my first foray into the world of social media data. I'd been doing lots of analysis on traditional media and politics, but this was my first foray into social media analysis, and I took it up with the 2014 September, October, November protests in Hong Kong, which came to be known as the Umbrella Revolution or the Umbrella Movement, Occupy Central as well. And the first thing that I went to do, of course, was to collect some data on this. And where did I go to? Naturally, I went to Twitter, because we all go to Twitter for this sort of data, right? But as a social scientist and as someone who is sort of obsessed with things like concept validity and reliability and construct validity, I wanted to know what the heck I was looking at once I had my hands on this data. And I realized I didn't have a really good sense, so I started reading some of the literature and I couldn't really figure it out. I started digging into the Twitter documentation and couldn't really figure it out, and so I launched this project. My major, well, I won't spend a whole lot of time going over the Twitter basics here, because I suspect that most of you for whom this is relevant know quite a bit about the Twitter APIs, but I still will give a very quick broad overview. There are several APIs that Twitter uses to make data available to the outside world. There's the Power Track, which is made available through GNIP. It's real time, and you are at least told you're receiving more or less 100% of all data. It is, however, cost prohibitive. Then there are various tools available, or you can write your own programs to access the streaming API, which is also real time and maybe a sample, maybe not. The documentation is unclear. It says you can return up to 100% of all data within certain parameters. Then there is the Search API, which is actually a part of the larger REST API. And most people use the Search API to collect data that's historical in nature. You can actually use it in a way that makes it function more or less as the stream, but it has much more significant limitations to the amount of data that you can actually collect from it. And then there's the archive, which is not an API, available through GNIP. And it is a collection of all tweets since Twitter was started in June 2006, sort of. And I'll get to the sort of in just a minute. I'm focused here on collecting data through keyword queries. There are other means by which you can access data from the APIs. The keyword queries are probably the most popular way to access this data, and in many ways the most problematic. The streaming API allows, as I said, real-time capture, and it can capture up to 1% of the global volume. And if your query goes above that 1%, you will definitely be rate limited. Whether you will get 100% below the 1% is actually kind of a question mark for us. But we do know, right, if the issue or event that you're searching, you're querying, let's say on a hashtag, is particularly popular, you are likely to be rate limited. If Americans have gone to sleep or are on vacation, there's a much higher chance that you're going to be rate limited because Americans simply produce the most volume on Twitter globally. The streaming API allows you to query keywords from multiple areas. So you can query the text, it queries quoted text, URLs, hashtags, and mentions, and this is the same as the Power Track. The search allows for historical capture by keyword or username, but it queries only the text. So you don't get the same results from the same query. Even if you could get 100% matches, it would not be the same as querying via the Power Track the full population, because you're actually querying different fields within a tweet. There are significant limitations to any return on the search API. I'm not going to go through all of these here for you. It's enough to know they are quite significant, and I suspect many of you already know what these are. One thing that is important to point out here, though, before I move on, is this point about top tweets. This is in Twitter's documentation. They tell us that the search API doesn't return anything. They prioritize, quote unquote, top tweets. So part of my curiosity is, what is a top tweet? What makes something top? And then we have the archive again, which is, as I said, not truly a record of all tweets because it doesn't contain any tweet that has been deleted or made private, gone from public to private status. And Twitter's terms of service actually require that every one of us that holds on to Twitter data, that stores it in some form, delete those tweets that have been deleted from the archive ourselves. So any of you, including myself, holding Twitter data right now, I guarantee we're violating Twitter's terms of service. Okay, let's talk briefly about a couple of studies that have come out and helped me think about this a little bit more. One by Driscoll and Walker and one by Morstetter and colleagues. Both of these studies compared the power track to the stream only. They didn't look at the search. Driscoll and Walker looked at 2 cases in which they were, in both instances from the stream capture, they were rate limited, and they did only a tweet count comparison. They did, however, achieve 100% capture in the stream during the periods when they were not rate limited. Morstetter et al. Were also rate limited, and they did not achieve 100% capture from the stream even when they were not rate limited. They did further analysis beyond just looking at the tweet count comparison. They looked at top hashtags, topic analysis, and network centrality measures to get a sense of how much bias there was. And indeed, on each and every one of these, they concluded that the results were quite problematic. Now, let's talk about my own data collection here. I have lots and lots of data. I'm going to be talking to you today primarily about 3 data sets that I've used. I'm going to throw in a surprise one at the end, but I'll start by introducing these 3. These are 3 what we might call hashtag events. We queried on hashtags, and we collected using the same parameters, same query parameters across all 3, well, the 2 APIs and the power track. The first of these was hashtag joint session. This was Donald Trump's first address to Congress, normally called the State of the Union, but when it's the president's first, it's not yet State of the Union address, it's the joint session. Twitter officially sponsored this hashtag, and we knew going in it was going to be massive. So it was incredibly high volume. We captured for 3 hours, and it was rate limited from beginning to end. The next was hashtag AHCA from March 24th of this year. This was the failed vote in the US House of Representatives on the health care bill. And this was more what I would classify as a medium volume event. We captured for 8 hours, and we didn't actually encounter any rate limits during that period. Then finally, hashtag FOMC. Probably no one has ever encountered this. It's an obscure one on purpose. This is the Federal Open Market Committee. When the committee meets, I think it's 8 times per year, they then do a press conference and usually have some little announcement in there that's pertinent to the financial world, including talking about interest rates. So we captured during their press conference following the July meeting. This was low volume. We captured just for 1 hour because effectively after that hour the hashtag disappeared, and we encountered no rate limits. Our search parameters, right, for the search API, we started the queries shortly after the track and stream were terminated, and we ran them until 500 consecutive queries or calls returned no new data. So these are our basic numbers. For the track, for our big event joint session, we had almost 570,000 tweets. The stream, which I said was heavily rate limited, captured about 65% of those. Excuse me. And the search actually performed in terms of, right, simple percentage, a bit better than the stream did, capturing 67% of the overall volume. AHCA and FOMC, neither case were we rate limited, and we actually got about 100%. If you notice, interestingly, with the AHCA hashtag, we actually got more in the stream than we did from the power track. Right? This is already an indication of some of the infrastructural issues that can come up. GNIP says this is full population, but actually it's slightly off here. We have more from the stream than we do from GNIP. But for search in both instances, we achieved significantly lower, so about 67% and then about 85%. And of course, the FOMC is a very, very small volume in comparison to the others. Now, the first question that we are interested in here is simply, is bias likely to be introduced when data is collected using either the stream or the search API? And the first way that we went at this question was to examine the data using Kendall's tau, which is a correlation of ranked objects. And we used this, we applied Kendall's tau to top ranked lists of top hashtags, mentions, and usernames. So how closely correlated are those ranked lists across the different data sets? And our answer here is that it's highly likely, bias is highly likely when the stream is rate limited, and in almost all cases for the search. So quickly present some of the basic data here. We'll start with the small volume data. For the hashtags, we didn't have, I wouldn't say too many problems here. The correlations are quite high. But for the mentions with the search data, right, we start running into some problems. And then the numbers are quite problematic for the user's data. So what does this mean? What this means essentially is if you were interested in drilling down or making some sort of inference based on the top users within a data set, right, you'd have some problems in front of you. And in fact, the correlations are so poor that we could with almost certainty say that there's pretty strong bias. There would be pretty strong bias in the results that you, or in the conclusions that you drew from this data. Then looking at the AHCA data, we see that the search has problems all the way throughout. The users' results here are shockingly poor, right? 0.26 correlation in the top 10, just 0.10 or 0.11, going all the way down to 0.02 correlation for the top 100 users in your data sets. Joint session, now we have rate limits introduced into the stream, and so we get to see what happens there. And indeed, we immediately start seeing problems with the hashtags, goes across to the mentions, and users, oh, that should all be highlighted in red as well, because it's particularly bad there. Okay, now what I think is the most interesting, fun part of this project, we started looking into what factors might be driving the API samples. Now remember, Twitter has told us that it is sampling the search data based on top status. So to me, that signals that there's something going on algorithmically here, right? They're not just pushing a throttle button, it's not random. Stream, we don't know whether it is just a throttle button, whether it's essentially random, or whether there's something, a larger pattern here to the choices that are made algorithmically about what we don't get when the data is rate limited. So we've looked at a number of different variables. First, we considered user characteristic variables, questions that might inform the quote-unquote decisions, right, about how data is pushed out to the user, include how prolific the user is. So we would look at their overall Twitter volume, their overall tweet volume, and their status counts. Their likes count is how many likes they have actually, how many tweets they have liked themselves, not how many likes they've received. How popular, right? How many followers do they have? How engaged are they? So measured by how many they're actually following themselves. and some sort of measure of prestige / authenticity here in terms of whether or not the account is verified, whether it actually has a bio in place, and how many lists that user is present on. And then we looked at tweet characteristic variables. So in terms of originality, we asked, is it a retweet or not? Is it a quote tweet or not? Engagement with others, how many mentions of other people are in the text of the tweet? Is it a reply to another user? Then we asked about engagement in discourse. We were curious about this. So how many hashtags did someone include in their tweet? Content richness might be assessed based on whether or not there's additional media provided in the tweet. And of course, a basic measure of popularity. So how many times was the tweet liked? Just a very nitty-gritty, down and dirty, a couple of pieces of information I think you need to know about the models that I'm about to present to you. This is, as I said at the very beginning, work in progress, and these are just our preliminary models. And so they're really the most simple models. We've thrown all the variables in them. We haven't done any transformations to the variables. We haven't used interaction terms yet. And I think crucially what's missing at this point in terms of omitted variables is some measure of potential bodiness, all right, with each of these accounts. But we're working on putting all of that data together now. Okay, so this is a massive list of results from our regression analyses. I don't expect you to read all of this in a minute. I'm going to highlight some key things here. These are all the results for the search data across our 3 different data sets. And what I've highlighted in green here is the only variable that across all 3 data sets remains consistent. So it has for the hashtag count, we know that an increased number of hashtags, the more hashtags you have, the more likely the tweet is to appear in the sample, the search sample. But I'm now going to take that last data set out of the equation for us because it's so small, right? Just about 1,000 observations. We're asking it to do a lot of work, and a lot of the variables that are in there simply don't have a high level of variation. So I'm going to have us focus on the first 2 models. And here I've highlighted where we have consistency across these 2 models, right? In terms at least of the direction of the effect and whether they show up consistently as statistically significant. But even more important than this, right, I want to focus a little bit on the idea of the actual effect size or the impact of each of these variables. And so here I've highlighted some of the variables that I think are interesting in terms of the odds ratios that they report. If you look at the verified variable, right, indeed in the search it shows up and has a fairly strong effect that if an account is verified, it's more likely, the odds are higher that it's going to show up in the search sample that you receive from Twitter. Retweets, interestingly, have a pretty significant effect size in both instances, but the direction, right, of the coefficient is the opposite in these 2 data sets. So what we expected was that retweets would be less likely to appear. If we're thinking about top tweets, we thought originality would be prized by Twitter. But it's not consistent here. And then one of the things that is really consistent across all the data sets that we look at is the hashtags here, as I showed you on the last screen, plus it has a fairly important effect size. Now, this is where I'm going to bring in the little surprise I promised at the very beginning. I'm beginning here with the streaming data from the joint session data set that I talked about. But I also have a second streaming data set to share with you. This is the @RealDonaldTrump data set from his inauguration. So this data set we collected for 8 hours on the day of his inauguration. And from the power track, there were almost 1.3 million tweets versus the stream, which captured about 67-68% at 872,000 tweets. We don't have any search data because when we tried to capture immediately after we stopped both the power track and stream captures, the search already would not go back historically and get anything. That was 15 minutes later. 15 minutes later, we couldn't get anything from the historical search. So we just have those two data sets to show you. Now, let's look at, is there consistency? Through a lot of the variables there is, but one thing I really want you to notice here is that two of the variables don't appear at all, right, in the real Donald Trump data set. We're capturing this at the end of January, joint session at the end of February, and GNIP, right, didn't have these two variables. Quote tweets existed at the time, lists existed at the time, but they weren't available. So this is already pointing to one of the main conclusions that I want to draw out for you today, which is simply Twitter is a moving target, always a moving target. In terms of the effect sizes, verified, again, has a fairly significant effect on on the odds of appearing in the stream sample, but notice it's now negative. That makes absolutely no sense to me intuitively, right? The same with bio, retweets. This is where I actually expected, you remember with the search data, that retweets would not be prioritized, would be demoted in effect, and that's what we see with this data. So more or less, right, we've got some, essentially what I can say is we've got some odd things happening here. Things we simply didn't expect when we started out thinking about what might lead to, what might drive the factors behind the data selection here. So, with the qualification that this is, again, preliminary in nature, these are the things that I'm thinking about. The streaming API without rate limits does seem to be approximating the full population, but based on previous research, we know that's not a guarantee. And because Twitter is indeed a moving target, right, it could be that tomorrow I go to capture streaming data and I will never ever again get 100%. We simply don't know. Even if it were possible, of course, local infrastructure issues as well as GNIP outages can hamper our ability to get the data through the stream. And of course, as I just said, Twitter itself is a moving target. All Twitter APIs are a moving target. Why this is really problematic is it means ultimately we simply don't know what we don't know. We do know, in terms of the stream, when we're being rate limited. So if you're not getting the rate limiting messages, right, you can be fairly confident that you've got a high volume, but not certain that you've got 100%. And even if indeed Twitter is just hitting a random throttle button, right, when we hit rate limits, even if there's no logic behind the idea of the top tweet for the search API, and indeed what we're getting is a random result, for individual queries, that could still have very large implications for the conclusions that you're going to draw. Retweets may be higher, they may be lower. And if you don't know and you're basing your analysis on retweets, right, you don't know what you don't know. Now, quickly ending by taking this beyond Twitter briefly, because even though we all like Twitter an awful lot, there is a world of research beyond Twitter. Of course, we know that APIs all carry limits on data capture, and most of those that are available to us are much more severe than Twitter actually is. And so there are always mismatches between what we need and what we can actually get our hands on. So one of the key questions is, do we reformulate what we're asking based on what we can get our hands on, or do we keep going after our original research question and our original hypotheses, whatever they may be, but include all of these very significant caveats. Of course, without access to any of these algorithms, we never know what we don't know. It's not just a problem with Twitter, it's a problem with all of the digital data that we're trying to access. And we simply have to be much more open about these limitations. Right? In methods sections in social scientific papers, we need to be reporting on these things and being honest with our colleagues. Right? I'm a political scientist. In political science, most of my colleagues know nothing about Twitter. They leave it up to us to know what we're doing. Most of us within political science who are actually working with Twitter data leave it up to our computational colleagues to make those decisions for us. Right? We need to get better about understanding these things, and we need the computational scholars amongst us to help us understand it better as well. Then I would also say that it's important to remember that not only how we capture in terms of the various APIs matters, but the moment of capture actually matters. And this matters at least in two crucial ways. One of these is in terms of data decay. So the moment, we were having a discussion in the last breakout session in my group about how the moment you capture data from Twitter, it becomes instantaneously non-reproducible, right? Because tweets disappear constantly. People delete their own tweets, they shut down their accounts, Twitter shuts down accounts, they take their data private. On the internet, data disappears very quickly. Second, we need to be thinking a bit more about the implications of the moment of capture for the metadata that we're looking at. So if I capture data in real time from Twitter or from Facebook or whatever, right, it's not going to have likes on it. For Twitter, it's not going to be retweeted if I'm getting it at the moment of its initiation. But if I'm interested in number of likes, number of retweets, the things that are driving those, then I have to capture that data historically. As soon as I do that, I have issues with data decay, API issues, right, and not being there. But even if, right, I decide that I'm going to capture, I need a count of likes, I have to decide what the moment in time is to get those likes. And making comparisons across different tweets or different Facebook posts produced at different points in time, right? But I'm capturing only at one point in time, has significant implications for the sort of inferences that I can draw. So, to leave you on a rosy note, I'm just going to say thank you.